Okay, in this video, we're going to start with chapter 5, which is time series. Okay, look at brief introduction on what is time series. Okay, time series is a set of data observed over a period of time, usually of equal intervals of time. So what is meant by equal intervals of time? So the interval can be hourly, or it can be daily, weekly, monthly, or yearly data. Okay, I show you an example of time series data that I had. Okay, here I have data about air pollution at Sarawak on year 2018. So if you look at here, I have data for several places in Sarawak. So this data is an example of time series data that are collected by hourly. Okay. So if you look at here on 1st January, so the air pollution index has been collected. For example, here at 1 a.m., 2 a.m., 3 a.m., 4 a.m., and so forth. So if you have data like this, means that this data is a time series data that we collect it by hourly. Okay, inside of this data also, we collect data on daily basis. Daily basis means that, so this is 1st January. So we also have data on 2nd January, 3rd January, 4th January, and so forth. Okay, so this data also can be interpreted as hourly data as well as daily data. Okay, now look at why we need to study about time series data. Okay, so the purpose of studying time series is to identify the fluctuations due to seasonal factors so that we can remove them from computation in forecast or prediction for future planning. So purpose in time series is we want to do forecast or prediction. Okay, so when we do forecast or prediction, it can be used for future planning. So example of application of time series, normally we apply it in budgetary control or stock holding, investment in stock and shares. So this is the 4 components of time series. So we have trend, cyclical, seasonal and irregular. So I hope you already watched the video that I suggested to you on the detail about each components under of time series. Okay, here I briefly explain again. So trend, what is trend? It can be defined as the long-term general movement where the value of the variable tends to increase or decrease over a long period of time. Normally, that long period of time is normally we consider within 10 years. Okay. Okay, cyclical. So normally, cyclical in time series, it refers to the rises and falls of the time series. Okay. The movement repeat patterns over a period of time. Normally, we observe within 2 or 10 years. So in cyclical, there is no specific period of time when the cycle will occur. But in seasonal component, there is a specific time when the component will occur. We can see the component occur at certain period of time. For example, if you have a school uniform shop, so your sales will increase during end of every year. Okay, because in January, student will come back to school again. Or maybe during Chinese New Year, sales of oranges will increase as well. So you can see at certain period of time, the variable or value of the variable tends to increase or decrease. Okay, about irregular. So irregular is variations that describe the movement of a variable which completely unpredictable. Okay, usually caused by catastrophes. Or another example, current example now, number of tourists go to Japan or Korea is suddenly decreased, okay, or suddenly drop because of COVID-19 pandemic. Okay, or maybe another example is earthquake and tsunami that hit Indonesia during 2004. So maybe in that time, the occupancy rate in most of the hotels near the beaches was affected as well. Okay, that is brief summary for components in time series: trend, cyclical, seasonal, and irregular. Okay, so in this chapter, our main objective is we want to do forecasting, okay, or we want to do prediction. So under this chapter, we have moving average method, only one method, moving average method. So under this method, we divide it into two. Either we use simple moving average or centered moving average. So in this video, I'm going to show you on how to do forecast or prediction using simple moving average. Okay, before that, we need to know when to use simple moving average and when to use centered moving average. Okay, look at some introduction on the moving average method first. Okay, moving average is calculated by averaging the most recent end data values in a time series. So, end data values refer to the time series, whether it is based on hourly or daily, weekly or yearly or maybe quarterly. Okay. So with this method, it can be used to forecast the data value for the next period, but not for periods which are too far in the future. Okay, for example, now May 2020, so maybe we can predict at least July or August 2020, okay? So it is not suitable for us to predict, for example, we want to predict for 2025, okay, because it is too far. Okay, now look at on when to use simple moving average method and the centered moving average method. Okay, look at simple moving average. So simple moving average is used when the data are such that the period is an odd number of terms, okay, or odd number of time. Okay, examples: shops which are open 5 days a week. So what is meant by odd number? Yes, 5 days a week. So 5 is odd numbers, right? So if you have odd numbers or odd time here, we will use simple moving average. Later on, I will explain in detail. Okay, second one, maybe workers working on 3 shifts a day. So 3 shift, odd number. So if you have odd number like this or odd number of times, then use simple moving average. Okay, example, I have data here. So how to know this data is collected by weekly or daily, or we want to do forecast based on weekly or daily basis? Okay, first hint, you look at forecast question. Okay, this is forecast question. Forecast the number of patients who will be seeking treatment on Monday. So on Monday, meaning to say that later on when we want to do prediction, will be based on daily basis. Okay. Or you also can refer here in calculating seasonal indices. Okay, it asks you to calculate seasonal indices for Monday and Wednesday. So meaning to say that based on daily basis. Okay. So look at number of days that we had. 1, 2, 3, 4, 5. So 5 is odd numbers, right? So if odd numbers, so meaning to say that in this question, we're going to use simple moving average. Okay. So that's how you determine when to use simple moving average. If you have 3 days only, meaning to say that odd number as well, so use simple moving average. Okay, how about when to use centered moving average? So centered moving average is used when the data period is even number of terms. Okay, examples, sales that are recorded in 4 quarters. Okay, I show you example. Okay, if you look at this data, okay, how to decide whether to use simple moving average or centered moving average? Is it based on these 3 years? So if 1, 2, 3, 3 is odd number, right? So if odd number, we use simple moving average. But if you look at by quarter, we have 4 quarters. So there are 4 quarters, meaning to say that it is an even number of term. So if even, we use centered moving average. So how to know which one, simple or centered moving average? So again, look at forecast question. So forecast the amount of shipment in million RM for quarter 3. Okay. So we need to forecast by quarter. Or if you refer question seasonal index here, interpret the seasonal index obtained for quarter 1 and quarter 2. So we need to analyze this data by quarterly basis. So if you look at quarter, we have quarter 1, quarter 2, quarter 3, and quarter 4. So there are 4 quarters, means that even number of time or even number of terms. So if even number of terms in this question, we need to use centered moving average. Okay. Okay, that's how we determine on when to use simple and when to use centered moving average. So again, I summarize here. We use simple when the period of time is an odd number and centered when the period of time is even number. Okay, now look at example for simple moving average. So recall when to use simple moving average when the number of terms or the time is odd. Okay, odd example 3, 5, 7 and so forth. Okay, so here we have data about number of computers produced by a factory during the morning, afternoon and evening shift of the week. Okay, if you look at this data, we have day from Monday to Friday. So this one, if you calculate, there are 5 days, right? So odd number as well. 3 shift, morning, afternoon and evening. 3 shift, odd number as well. So now we want to focus by day or by shift. Okay, so if you're confused, you look at question first. Okay, look at focus question. Okay, forecast the number of computers produced during the evening shift on Saturday. So meaning to say that we want to focus by shift. Okay, so now look at shift. 1, 2, 3. So 3 shift, odd time or odd terms. So meaning to say that we need to use simple moving average. Okay, remember in time series, our main objective is we want to do forecast, okay, or prediction. So how to forecast or what are the steps that you need to know or to follow from question A until question D? Okay, you follow simplified note that I already give to you. Okay, you refer the simplified note. Okay, first step, you need to know whether you need to use simple moving average or centered moving average. Okay, let's say if you want to use simple moving average, first step, directly you create 5 columns like below here. Okay, so first column for year or like previous example, first column will be for days, second column for term or from previous data that I showed, second term will be the shift. Okay, 3 y here represent the actual data. So previous data, our actual data is about number of computers produced. Okay, fourth, okay, this is we want to find trend values. Okay, so how to find trend values using simple moving average? We find average of 3 shift first, for example. Okay, so why 3 moving average? Because we have 3 shifts. If let's say you need to focus by days and there are 5 days, so here will be 5 moving average. Okay. Okay, then last column you create 4 column seasonal variations. So later I will explain on how to calculate seasonal variations. So we need value seasonal variation in order to do forecast. Okay, that is for simple moving average. Okay, if you know that you need to use centered moving average, okay, directly you create 6 columns. Okay, similar to simple moving average here, this column, but you need to add another one column here for moving average. Okay, example, let's say the data was collected by quarterly. Let's say we have quarter 1, quarter 2, quarter 3 and quarter 4. Okay, so you create first 4 moving average. Okay, why 4 moving average? Because 4 quarters. If you have data, for example, collected by days from Monday to Saturday, 6 days. So if 6 days, even time, so we still need to use centered moving average. So if you have 6 days, so here will be 6 moving average. Okay. Okay, after this column, you create column for trend values, which is for 2 moving average. Okay. So later on, I explain why here you need to put 4 moving average, and this one, the trend value is only under 3 moving average. Okay. And then last column, similar to simple moving average for seasonal variations. So remember, simple moving average, directly you create 5 columns. Centered, you directly create 6 columns. Okay, after you create this table, you need to tabulate the original data to this table. Okay, then you need to construct table for seasonal index. Okay, so value seasonal index here will be based on value seasonal variations. So later on, you need to tabulate this value seasonal variations into table seasonal index. So this one, term 1, term 2, term 3, if you have 3 moving average like this. Okay, so if you have 4 moving average by quarterly data, so here will be Q1, quarter 1, quarter 2, quarter 3 and then quarter 4. Okay, depends on your data. Okay, now how to forecast? Our main objective is we want to do forecast or prediction. So these are 3 main steps to forecast. Okay, first we need to calculate the average trend. Later I will explain detail about this formula. After we estimate the average trend, we forecast the trend value. Okay, so here if you look at this table, we have trend values. Here also we have trend values. So second step here, we need to forecast trend value. So forecast trend value meaning to say that we forecast value in future based on our previous data. For example, our data, last data based on, for example, this data. Okay, let's say we have last data Friday until evening. So we want to forecast, for example, what is the number of computers produced, for example, for Sunday on afternoon. Okay, so we have data until Friday, so we want to focus in future. In future, for example, number of computer produced on Sunday, for example. Okay, last step, we do the forecast or prediction. Okay, now let's move on to example. Okay, look at question A. Based on data above, calculate the trend values. Calculate the trend values. So you want to calculate trend values using the moving average method. So here we need to use simple moving average method. Okay, correct your answer to 4 decimal places. Okay, remember, if we use simple moving average, directly create 5 columns. Okay, you tabulate this data into 5 columns. Okay, you tabulate the data into table like this. So 5 columns just now is for day 1, 2, 3, 4, 5. Okay. So from this data, original data, you tabulate into this table. Okay. Now we have from data from Monday to Friday. Okay, if you look at forecast question, forecast the number of computer produced during the evening shift on Saturday. Okay, we want to forecast evening shift on Saturday. So you add until Saturday here because we want to focus on evening shift on Saturday. Okay. So units here refer to number of computers produced. Okay. If we have odd number of terms or odd number of times, meaning to say that here referring to shift, morning, afternoon, evening. So the three moving average will be the trend values. Okay, why we call it a simple moving average? Okay, we want to find the center value. Morning, afternoon, evening. So center will be at afternoon shift. Okay, so that's why we call it as simple moving average. Okay, what is meant by moving average? Okay, since we have three shifts, so how to find average? Total up three values and then divided by 3. Okay, why divided by 3? Because we total up three values. If you have data 5 days, for example, you need to forecast by day. Okay, if 5 days, you total up 5 days, for example here, 1, 2, 3, 4, 5. Okay, so if 5 days, 1, 2, 3, 4, 5. So which one is the center will be on third day here. Okay, so third day will be the center. So that is meant by simple moving average. Or if you have 7 days, you need to forecast using 7 days. So Monday to Sunday, center will be on Thursday. Okay. Okay, now look at how to find the trend values or the three moving average. Okay, again we have three shifts. So you find average number of units or number of computer produced from these three shifts based on Monday. Okay, so morning, afternoon, evening, center will be on afternoon shift. So how to find the moving average here? So you total up these three values first, okay? Total up and then find the average. So how to find the average? So center on afternoon shift. So here you can calculate like this. 255 plus 224 plus 241. So total average divided by 3. So this one you will get 240. So based on these three shifts on Monday, the average unit produced for computer is 240 units. Okay, now how to get moving average for second value here or second trend values. So this one we call it as first trend values, FTV. FTV is first trend value. Okay, moving average. Okay, you move one value means that you discard this value and then you add another three values here. Okay, another three values. So you add another three values here. So that is made by moving average. So second trend value here will be 224 plus 241 plus 234 and then average divided by 3. So second trend value is 233. Okay, third trend value, again, you move one value here, then you add another three values here. So here will be 241 plus 234 plus 239. So make sure you copy data correctly. So this one you will get 238. Okay, continue until you total up the last three data. Okay, because we have three shifts. So here you move this value and then add another three values here. So fourth trend value will be 234 plus 239 plus 250 divided by 3. So here we will get 241. Okay, continue the same process until you total up the last three data. So move this value, add another three data. Okay, once you get the step, okay, it is not necessary for you to write this one by one. Okay, you can directly press your calculator and then just put your trend values here. So for example here, if you continue the process, so trend values here you will get 240, next 242, here 243, 241, here again 242, here also 242, here 243. Okay, last trend value. Okay, how we get this one last trend value? So this one should be, you need to add the last three values here. So once you utilize or you total up last three values, then you stop. Okay, so here will be 240 plus 230 plus 256 divided by 3. So last trend value here is 242. So this one we call it as last trend value. Okay, that's how to answer question A on how to find trend values. So here is the first trend value. This one will be the last trend value. So here maybe you can just put dash, means that there will be no value here. Okay, now look at question B. Calculate the seasonal index for each shift. Okay, so you want to calculate the seasonal index. So how to calculate seasonal index? So we need to calculate seasonal variations. Okay, on the fifth column here. So S equal to Y divided by T multiplied by 100. So what is Y? Our original data here. And then T referring to trend values. Okay, so start with first trend value. So our first seasonal variations will be Y224 divided by T 240 multiplied by 100. So this one we will get 93.3333. Okay, so if you have long decimal points, so you round off your answer to 4 decimal places. Okay, second seasonal variations, Y divided by T. So Y is 241 divided by T 233 and then multiply by 100. So equal to 103.4335. Okay, continue the same process. So here you will get 98.3193, 99.1701, and so forth. Okay, you continue the same process so until last trend value. So here until last trend value, last one seasonal variations, you will get 95.0413. Okay, how to find or how to calculate seasonal index? Okay, so we need this value seasonal variations in order to calculate seasonal index. Okay, then why we need to calculate seasonal index? Because we want to do the forecast or we want to do the prediction. Okay, now we need to tabulate value seasonal variations into table seasonal index. Okay, so if you look at this simplified notes, once you've done this part, then you need to tabulate the seasonal variations to calculate seasonal index. So you put into table like this. So here will be the day, Monday to Friday, and term here will be the shift, morning, afternoon, evening. Okay, now let's tabulate value seasonal variations into table seasonal index. Okay, you create table for seasonal index like this. So here will be the day, Monday until Friday. So next column will be the shift, morning, afternoon, evening. Okay, until last day, Friday here. Okay, you put row for total, and then row for mean, and then row for total mean, row for correction factor. Later I will explain. And last one is row for seasonal index. So our main objective here in question B, we want to find seasonal index. Okay, once you create this table, okay, put all the seasonal variations value into this table. Okay, for example, if you look at previous table, okay, start from afternoon shift on Monday, seasonal variations is 93.333. So there is no seasonal variations on morning shift for Monday. So here, we just put dash. And afternoon shift, the seasonal variations is 93.333. Okay, then you transfer all these values into table seasonal index. Okay, copy correctly. Make sure you misstep from first step here. Make sure you enter data correctly. Okay, once you enter data incorrectly in the first step here, all things here, all your calculations here will be affected. So here will be 103.4335 and then continue until last value of seasonal variations. So if you look at here, there will be no seasonal variations for Friday in evening shift. So Friday evening shift, there will be no value for seasonal variations. So morning shift on Tuesday is 98.3193. Next, 99.1701. Next, 103.3058 and continue until last value. Okay, transfer all data. Okay, once you transfer all seasonal variations, okay, next step, calculate total seasonal variations for each shift. Okay, so here, total variation for each shift. So if you total up 98.3193 until 95.1736, here you will get 391.8280. Okay, total seasonal variations for afternoon shift is 477.6274. And last one, 419.1131. Sorry, 39. Okay, after you find total, then find mean. So again, how to find mean? You total up and then divided by n. So example here, for morning shift, so you total up how many data? 1, 2, 3, 4. Okay, so 391.8280, 391.8280 divided by 4. Okay, because you total up 4 data. So here you will get 97.9570. Okay, for afternoon shift, 477.6274 divided by, so how you get this value? You total up how many numbers? 1, 2, 3, 4, 5. So divide by 5. This one you will get 95.5255. So similarly, this one 419.1139 divided by, so how many numbers you total up just now? 1, 2, 3, 4. Okay, next, once we find the mean, find total mean. So what is meant by total mean? You total up these three values. Okay, 97.9570 plus 95.5255 plus 104.7785. So equivalent to 298.2610. Okay, so later on you can press calculator directly. So no need to write this one by one. Should be no problem. Okay, you just write final answer also, no problem. Okay, once we get the total mean, okay, look at correction factor. What is meant by correction factor? Okay, we need to look at total mean here. Okay, now we have 3 shifts. Okay, so before this, we calculate seasonal variations, we multiply it by 100, right? So meaning to say that for each shift, we should get 100%. Okay, if you look at total mean here, we only get 298.2610, means that not exactly 300. So when to calculate correction factor, if total mean is not exactly equal to 100, okay? Or if you get more than 300 also, you need to calculate correction factor. Let's say here, you total up, total mean you get 321.3. Okay, so this one also not exactly 300. So you need to do correction factor. Okay, remember if you did not get exactly 300, either less than 300 or more than 300, we need to do correction factor. Okay, that one, correction factor. Okay, if you look at your note on page 100, okay, look at step 5. Okay, calculate the total mean of S referring to seasonal variation. Okay, if the total mean is exactly equal to the number of time periods, our data based on shift, okay, morning, afternoon, evening, multiply by 100, or number of columns. Number of columns just now means morning, afternoon, evening, okay, times 100. So that's why we need to get exactly 300 because we have 3 columns. Okay, the value of the mean for each time period is taken as the seasonal index of each period. Okay, so if you get exactly 300, that one will be the total mean will be the seasonal index. Okay, don't worry, I will explain later on with the example. Okay, if let's say our data is by quarter, means that we have 4 quarters, so the total mean should be equal to 400. Okay, 4 columns for each quarter multiplied by 100, so it should be equal to 400. So when we get exactly 400, no need to calculate correction factor. If you get less than 400 or more than 400, then we need to calculate correction factor. Or if you have 12 months data, so you should get total mean equal to 12 multiplied by 100 is 1200, right? So if you get exactly 1200, no need to calculate correction factor. So this part, if the total mean is not equal to the number of time periods times 100, as I said, if we did not get exactly 300, find the adjusted mean value, which is the seasonal index. Okay, so this is done by computing the correction factor. So how to calculate correction factor? Number of time periods times 100 divided by total mean. Okay. So this is on how to calculate seasonal index. After this, we go back to this formula. Okay, look at how to calculate correction factor here. Number of time periods times 100 divided by total mean. So if we have 3 columns just now, morning, afternoon, evening, so 3 columns, multiply by 100, 300. Okay, divided by total mean. Okay, go back to this table. Okay, how to calculate correction factor just now? Number of columns or number of time periods times 100. So meaning to say that we should get 300. So if you have 4 columns, you should get 400. Okay. So divided by total mean, 298.2610. Okay, normally we need to calculate correction factor because in real life it is very hard to get perfect data. So means that if you get exactly 300, means that perfect data. But most of the time we need to calculate correction factor. So 300 divided by total mean here, we will get correction factor equal to 1.0058. Okay, you round off your answer to 4 decimal points. Okay, let's say you get correction factor like this, 0.9987. So if you round off, this one will be equal to 1, right? So no need to put your answer 1 here because 1 will be perfect. Okay, means that 300 divided by 300 will be 1. So if you get value something like this, just let your answer to be 4 decimal point like this. Okay, now look at our main objective. We want to calculate seasonal index. So how to calculate seasonal index? Seasonal index, or we call it as adjusted mean value. So seasonal index equivalent to mean for each time period, means that mean for each shift multiplied by correction factor. So seasonal index for morning shift will be mean multiplied by correction factor 1.0058 equivalent to 98.5252. Same step for afternoon and evening shift. How to calculate seasonal index? Mean multiplied by correction factor. Okay. So here you get seasonal index for each shift. After this, we will look at on how to interpret or give meaning to value seasonal index. Okay, now question C on how to interpret the meaning of seasonal index. So this question asks you to interpret the meaning of seasonal index for morning shift. Okay, so here I will show you on how to interpret for all shifts. Okay, how to interpret seasonal index? Okay, refer your notes on page 99. So here look at interpretation, the value of S means that value seasonal index. Okay, so look at the first one. If seasonal index S is more than 100%, then the actual data or the Y value. So example, based on our example, Y will be the number of computer produced. Okay, so if S more than 100, the actual data is S minus 100% above the trend. So more than 100, for example, we get 120. So 120 minus 100 is 20. So the actual data is 20% above the trend. However, if S less than 100%, the actual data is 100 minus S percent below the trend. So if less will be below the trend. Okay. Above we also can say increase. Below we also can say decrease. Okay. So 100 minus S, for example, S equal to 80. So 100 minus 80 is 20. So we can interpret like this. The actual data is 20% below the trend. Okay, if S is exactly 100%, so means that the actual data is exactly equal to the trend. So means that actual value equivalent to what we predict. So that's why I said before, in real life, it is very hard to get perfect data. Okay, now look at question C. Okay, we interpret for morning shift first. Okay, seasonal index for morning shift equal to 98.5252, below than 100%. So 100 minus 98.5252 is 1.4748. So we can interpret, so if less than 100%, we can say below the trend or decrease by how many percent. Okay, below also equivalent to decrease by how many percent. So the actual data, so now our actual data is about the number of computer produced on morning shift is decreased by, or you can say is how many percent above the trend, is decreased by 1.47%. Okay, the number of computer produced on morning shift is decreased by 1.47%. Or you also can say like this: the number of computer produced on morning shift is 1.47% below the trend. Okay, so if decrease means that below the trend. Okay, similarly for afternoon shift, less than 100%. So if less than 100% means that decrease by how many percent? Okay. Okay, now look at evening shift, which is more than 100%. So evening shift, the seasonal index is 105.3862. Okay. So this one minus 100, 105.3862 minus 100, we get 5.3862. So we can say that the number of computer produced on evening shift is increased by, increased because more than 100%, 5.39%. Or we also can interpret it as the number of computer produced on evening shift is 5.39% above the trend. Okay, because more than 100%. Okay, so that's how we interpret value of seasonal index. More than 100% increase, less than 100% decrease. Or more than 100% above the trend, or less than 100% below the trend. Okay, now last question, main objective in time series, we want to forecast or we want to predict. So here we want to forecast the number of computers produced during the evening shift on Saturday. Okay, so we have data until Friday. Now we want to predict value in future, which is on evening shift on Saturday. Okay, so how to do this part? You follow the 3 steps in forecasting. Okay, so if you look at simplified note here, steps to forecast. First, we need to find the average trend. So how to find average trend? 80 is average trend, equivalent to last trend value minus first trend value divided by n minus 1. So what is n here? N referring to number of trend values. Okay, now let's calculate average trend values first. Okay, so here is average trend. Okay, look at what is last trend value, first trend value, and number of trend values. Okay, go to first table here. Okay, first trend value is 240, last trend value is 242. So n is number of trend values. So what is number of trend values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, substitute the value. 240 minus 242, so n is 13 minus 1. 242, right? 242. So if you calculate this one, we will get 0.1667. Okay, that is first step in forecast. Okay, calculate the average trend. Okay, second step, we need to forecast the trend value for evening shift on Saturday. So forecast trend equal to last trend value, so which is 240 plus 80. 80 is average trend, 0.1667 multiplied by n ways from last trend value to forecast time. So what is this part? Okay, look at your first table. N ways from LTV, last trend value, to forecast time. So now our forecast time is evening shift on Saturday. Okay, look at the first table. So we want to forecast evening shift on Saturday. So n ways from last trend value. So means that here t equal to 1, t equal to 2, t equal to 3, and last one t equal to 4. Okay, so this is meant by n ways from last trend value to forecast time. Okay, so T equal to 4. So substitute here equal to 4. So this one we will get T equal to 242.6668. Okay, last step is to forecast the number of computer produced on evening shift on Saturday. So forecast equal to seasonal index multiplied by trend value. So this value divided by 100. So look at what is seasonal index for evening shift. Okay, look at table seasonal index. So evening shift seasonal index is 105.3862. So seasonal index multiplied by trend value, which is 242.6668 divided by 100. So this one we will get 255.7373. So since this one, the data is about number of computer produced, so it must be in integer, okay, or whole number. So this one we can approximate it equal to, so 255.7, so we can approximate it equal to 256 units, okay. So that's how we use simple moving average in order to forecast in future. So later on, if you are as a manager or supervisor on the factory, so you already forecast that the number of computers that will produce on evening shift on Saturday is 256 units. Okay, what is example that you can do, or what is the planning that you can do based on this forecasted value? Okay, let's say 256 unit is below average of production in your factory. So if below, what you can plan is maybe on evening shift on Saturday or Sunday, just now Saturday, okay, maybe if below than average production, what you can do is you can less hire worker, or maybe you as a manager no need to take more part-timer worker, okay. So because why, this will affect your budget, okay. So that is an example the useful of forecasting. Or maybe you know that next week will be more demand, so you know that 256 is the average production, okay. So you know that by next week you need to produce more because there is more demand as usual. So what you can do on Saturday, you need to hire more workers since there are more demand as usual, okay. So that is useful of forecasting or prediction that we can use from simple moving average. So later on, for centered moving average, the step is all about the same, but how to calculate the trend values is different. Okay, only different that part on how to calculate trend values. Step in forecasting still the same. Step 1, step 2, step 3. Only different in calculating the trend values.